Hey, this is a quick tutorial over how to find the number of protons, neutrons, and electrons in an atom and in an isotope. If you need to pause this because I'm going too fast, pause it, rewind it, watch it, the parts over that you're missing. So the first thing is the atomic number tells us the number of protons. That's the number in red there, and in blue the atomic mass gives us the number of protons plus the number of neutrons. The information on the periodic table is neutral, so that means that the number of protons equals the number of electrons. So when you're trying to find the number of electrons, you're using the atomic number also. Alright, now, another way we can write this down is that the atomic mass is equal to the number of protons plus the number of neutrons. And since the atomic number is the number of protons, we could write it also as the atomic number, the atomic mass is the atomic number plus the number of neutrons. So on the review sheet I gave you yesterday, one of the questions, similar to this one, I changed it up just a little bit, but lithium has an atomic number of 3. How many protons and electrons does it have? Well, the first thing you need to do is figure out what the problem is telling you. So it gave you the atomic number of 3. Okay, so we didn't have to have this box up here because in the problem it said the atomic number was 3. How many protons and electrons does it have? Well, the atomic number is the number of protons. And since that information is generally coming from the periodic table, that means the electrons are equal to the number of protons. So that means the electrons are also going to be 3. Alright, this is a problem straight from the worksheet yesterday. An isotope with an atomic mass of 39 and an atomic number of 19. How many protons, electrons, and neutrons does it contain? Alright, so using the formula above, we were given the atomic mass of 39. So I wrote that in there. We were given the atomic number. So I wrote that down right there. We were given the number of neutrons. Were we? No. This is what we're having to calculate. So we set this up in just a simple algebraic expression. 39 of the atomic mass equals the atomic number plus the number of neutrons. I need to subtract off this 19. So I have to subtract it from both sides. And when I do, I get the number of neutrons being 20 there. The number of protons is the atomic number. And a neutral atom, the protons equal the electrons, so that means that since there are 19 protons, there are also 19 electrons. So we have 20 neutrons, 19 protons, and 19 electrons. Alright, in this problem it says an isotope with 21 neutrons and an atomic mass of 40. How many protons, neutrons, and electrons does it contain? Okay, so we were given the atomic mass of 40, so I underline that in blue. So that's the number that we're going to plug in right there. And then I was given the number of neutrons. So I'm going to plug it in right there. So that means I'm going to be calculating the number of protons. So down here is where I showed you how to do that in an algebraic formula. So 40 equals the number of protons plus the 21 neutrons that were given. To get the protons by itself, I have to subtract off the 21 neutrons from both sides of the equation, getting the number of protons alone. And when you subtract 40 minus 21, you get 19 protons. Since the protons and electrons are equal to one another, they're both 19. And in the problem, it gave you the number of neutrons. So in this box right here is where I have the answer to that. So that was your very quick rundown on how to do these. Pause it when you go back to look at your problems to rework those out. Go back and find one of these problems and use this formula up at the top to help you out. Okay? Thanks.